Hey guys, welcome to chapter 19. In chapter 19, we're going to talk about electrochemistry. This is going to lead us right into discussion of how batteries work, basically. So, electrochemistry, we're going to study electricity. So, electricity really is just the flow of electrons. So, we spent the good portion of General Chemistry 1 talking just about what electrons do. And now we're going to get to apply that to another scenario, and that scenario is going to be electricity, so the flowing of electrons. Electrons will flow from negative to a positive charge. Remember, electrons are negatively charged particles, so it makes sense that they will be repelled by negative and attracted to a positive charge. Moving electrons can produce things like light and heat, so it produces usable energy for us. Okay. We are going to be studying the flow of electrons. So the type of chemical reactions that we are going to be studying in this chapter are going to be redox reactions. So redox reactions is short for oxidation reduction reactions. And I have posted a review video for oxidation reduction reactions if you are a little bit foggy on assigning oxidation states, a little bit foggy on looking at how electrons transfer over a chemical reaction. So I highly recommend you check that video out before getting much further into this chapter. All right, so flow of electrons. I said that electrons moving can produce light and heat. So a couple examples of flowing electrons causing light and heat would be in a battery. So we can use the energy in a battery to do things, but we also know that that tends to generate some heat in those batteries, right? And then the other example would be lightning. So lightning is just simply the flow of electrons, okay? So let's talk about lightning real quick. So when you've got this big old thunderstorm, these big clouds forming, what starts to happen is there starts to be a separation of charge within those clouds. So at the top, we see that there's going to be some positive charge at the top of the cloud where the ice is real high up in the sky. At the bottom, so the bottom of the cloud where we can see it, that's where we see a lot of the negative charge start to store up, okay? So as these storms start to gain a little bit of steam, a little bit of energy, we see this large separation of charge at the top and the bottom of the cloud. When the separation is large enough, what happens is some sort of channel of ionized air forms. So at some point, the charge is so big and so is a large enough separation that something reaches down and tries to neutralize that. So the instability in that separation of charge, we want to gain stability in chemistry. There's some sort of channel of ionized air that forms. That ionized air acts as a wire, so it allows the charges to travel and therefore equalize. So if we've got positive on the top, negative on the bottom, that channel of air acts as a wire, essentially, and allows the charge to travel and then equalize. If that channel of air happens to kind of fall out and touch the ground, that's where we see the cloud to ground lightning. So looking at these two examples here, this would be the lightning that's just staying in the air. So those channels of ionized air, those wires, if you will, just remaining up in the sky. We see that equalization process happening. If those wires happen to kind of fall out of the bottom of the cloud and then reach down to the ground, that's where we see the cloud to ground lightning. So that channel of ionized air is allowing positive, negative, and then it just falls to the ground. This is when lightning touches the ground, and then it will share that charge with anything that it touches in a very dramatic fashion. Okay. So that is our lightning. That's how lightning forms. That's how we see the travel of electrons. Here we see a battery, and what you'll find is that this works very similar to lightning. So we're going to have one end where we strategically cause a positive charge to the positive terminal. We have another end where we strategically have a negative charge to the negative terminal. So top of the cloud, bottom of the cloud, right? And then we're going to have some sort of channel that connects the two. So in this case, it happens to be graphite rod that connects the two. Okay. So what we're going to see here, and then another rod, I should point this one out too. So this is one rod that is going to be what we call a cathode. We'll talk about that in a minute. And another rod made of zinc, which is an anode. And then the rest of this is just kind of filling to insulate this process. So when we want the electrons to transfer, when we want the electrons to move, what we're going to do is allow these rods to transfer electrons from this positively charged terminal, from the negatively charged terminal to the positively charged terminal. And as those electrons are moving, it's going to create some electricity for us to use to power our toy or our remote or whatever it is that we want to charge. Okay. So reactions that create a flow of electrons. So we as chemists are interested in chemical reactions. So yes, we can talk about batteries and lightning, but we're more concerned with reactions that would cause electrons to flow. These are called redox reactions, which is short for oxidation reduction. So in a redox reaction, there's going to be some sort of oxidation that takes place, some sort of reduction that takes place. You cannot have one without the other. Both have to be present. If somebody's getting reduced, somebody else is getting oxidized. If somebody's oxidizing, somebody else is getting reduced, so on and so forth. So how do we know what is an oxidation and what is a reduction? Well, we're going to watch the flow of electrons. So whatever chemical loses electrons during a chemical reaction, that is going to be the chemical that we say has been oxidized. And whatever chemical gains electrons during a chemical reaction, that's going to be the substance that is reduced. So again, we're just going to be watching the flow of electrons. Somebody's gaining, somebody's losing. Okay. How do we know who gains and who loses? Well, that's where we get our oxidation numbers. So like I said before, I do have a video of oxidation numbers just to remind you the rules for establishing oxidation numbers, and then moving forward, looking at how those oxidation numbers change over a chemical reaction. Okay, so that's it for the introduction. What we're going to get into next is looking at redox reactions. We're going to look at an unbalanced chemical equation, balance those redox reactions. And then once we get to know these redox reactions a little bit better, we're going to put them into a couple different beakers, and we're going to start to make the electrons flow. So we're going to call that a voltaic cell. So those are the two big skills that we have left in this chapter. I hope you found this introduction helpful.